Hello, this is Bob Golding. I'm a senior escalation engineer at the Charlotte, North Carolina site. This is a continuation of my presentation on MPIO. On my previous presentation, we left off at the challenges regarding MPIO, and this is where we'll begin. The challenges are pretty obvious, I guess. Normal I/O is pretty straightforward, and errors are always more difficult. What kind of error is it? Is it happen to some other level, like a buffer overflow? Buffer overflows can occur on an I/O. For example, the read keys can return a buffer overflow, and the I/O has to be retried with a larger buffer to get the keys. That's not a failure. That's just programming error, basically. And then you have to determine the problem with the paths. Is a path failure? If it is, MPIO needs to be resilient to these and provide a minimum outage, or not to provide be pretty much transparent and recover from these resiliently. Things that need to be handled. Developing developing this is you need to. Very important to be able to distinguish between path failures and device failure. Path failure can be handled by MPIO. The path can be put out of service, but the device failure is different. We need to be able to distinguish between the two because we may want to send the error up to the upper layers and not try to handle it within MPIO. And what should you do? Should you retry? Don't retry. Try in a different path. Those are the challenges. Let's talk about some of the I/O paths in failover in the basic sense. Failover and handling a path failure. The I/O flows down. I/O request is sent down one path. The path fails. MPIO goes into failover, and the failed I/O requests are put on a queue, and new requests coming in are put on the queue, and I/O is suspended for the time while the failover is occurring. There are two queues in MPIO. One is a resubmit queue, and one is a dispatch queue. On the resubmit queue, requests that have failed and are going to be retried on a new path or put on a resubmit queue. The dispatch queue contains new requests while the failover is in progress. After failover is complete and a new path has been determined and the path taken out of service, the error requests are rerouted down the other path. And this whole process is, of course, known as failover. Now, failback. This is recovering from path failure. If a path has failed, I/O is set down the other path. This assumes maybe a two-path example. The path comes back online. The I/O request is sent down the original path, and this is called failback. MPIO maintains it's a timer that runs periodically to check once a failover occurs to see if the path has come back online. And once the path comes online, I/O is resumed down that path. Load balancing is another feature of MPIO, and load balancing is necessary to stop too many requests going down one path. So an I/O request is sent down one of the paths, and load balancing is handled by the DSM, and DSM determines which path the next I/O request to be sent down. Then the next I/O request is sent down the other path. It's pretty straightforward. The DSM makes the decision based on the load balancing policy of which path should be used for I/O. Now, what is a DSM? DSM stands for Device Specific Module, and it plugs into MPIO, and it's responsible for making a lot of decisions based on the storage devices. Now, should you fail over? Should you retry? It supports load balancing and path health. Microsoft has its own inbox DSM called MSDSM, which is available on the web and is extensible. And third-party vendors write their own DSMs, which is encouraged because a third-party DSM has a better understanding of the underlying hardware architecture and can make better decisions for errors in maintaining I/O flow efficiently. Like I mentioned, DSM has load balancing policies. Our MS-DSM supports 6 load balancing policies, and here in my MS-DSM supports asymmetric logical unit access and symmetric logical unit access, and based on what's implemented by the what's in the storage subsystem is handled a little differently, but basically it'll work the same. Symmetric, all paths are active optimized. Asymmetric or Lua, you may have standby paths, and our DSM will maintain I/O on the active optimized paths. Some of the load balancing policies, a little more detail, are failover only. Failover only is the one path is set as the active path, and it's a preferred path, and we'll try to send over that I/O over that path. In the event of a failover, one of the standby paths is chosen to become the new active path. But when the original path goes back online, we'll start sending I/O down that path again. Round robin is that's what it means. If you have 4 paths, for example, I/O is sent down 0, down 1, down 2, down 3, then we wrap around again. And that's only supported when all paths are in a symmetric state. That means they're all in the same state. If it's a Lua and you have standby paths and active optimized paths, round robin with subset would be the default. And what happens with round robin with subset is basically we just round robin within the active optimized sets of paths. Weighted path is the user decides the path weight, and based on the weight, it indicates the desirability of the path. The lower number indicates a more desirable path. The DSM always pick the path with the least weight. Least queue depth and least blocks are similar, where the decision is made in the DSM based on the activity on the particular path. Least queue depth will send I/O on the path with the fewest outstanding I/O requests, and least blocks sends I/O down the path with the least amount of bytes outstanding versus requests. The Pseudo-LUN has a state machine, and the state machine states are presented in the slide. And we cycle through the states when the failover occurs, and when the failover is completed, will either be normal or degraded. When the failover is completed, normal means that the all paths are online and functioning. Degraded means everything's online and functioning normally, except that at least one path is missing. In failover, the state we're currently involved in the failover. Pending failure is device has lost all paths and may be removed soon, and then from pending failure, if paths don't get restored, you go with the total failure and the Pseudo-LUN is removed. And the I/O is queued when the device is not functioning normally, and depending if all the requests are failed, depends on if you go into pending failure to total failure, or if the paths get restored and I/O can resume. This is a picture of the Pseudo-LUN state machine. Basically, we start with normal, and we go from in failover into wait 1 and wait 2 where requests are reissued, and then we could go into degraded if because one path has failed. If the path comes back online, we go back into normal again. And we could be in any state. We could go into pending failure, into total failure, depending on the state of the pads, or if you go to pending, does it back online through the wait states and back into degraded, depending on the state of the pads. And throttle is set by the DSM. DSM can throttle I/O, and this could be used sometimes if a report target group is in flight, which means the request could the target groups may be or the target ports could be reorganized. The DSM will tell MPIO to throttle a request, and then request will be resumed after the target port group completes and the ports and groups are reorganized. So we could so we go into throttled and back into normal degraded, okay, when the I/O is resumed. This is the flow, basic flow of I/O sent from a Pseudo-LUN to a port PDO in a real stack. Underneath the Pseudo-LUN lives all the paths, and the Pseudo-LUN, which is controlled by MPIO, works in concert with the DSM to determine where the I/O is sent, that is, which path the I/O is sent over. And as you can see in this diagram, we have the Pseudo-LUN, and the I/O is sent down from the user application down through volume manager, petition manager to the Pseudo-LUN, and then the I/O will be sent to the real LUN based on the path configuration. We're going to stop here. On the next session, we'll talk about I/O handling and more about the DSM. I hope you enjoyed this presentation and look forward to hope you join in the future.